Welcome everyone. Is it visible, this slide?
Yes, sir.
Yes, sir.
Set of 8086. Okay, so I would like to discuss today about the instruction set of 8086 microprocessor. So let's start with the instruction set. There are 9 different types of instructions are available in 8086 microprocessor. Starting from the data transfer instructions, then arithmetic instructions, logical instructions, branching instructions, loop instructions, shift and rotate instructions, machine control instructions, flag manipulation instructions, string instructions, etc. So one by one, I would like to discuss about the instructions classification. So let's start with the data transfer instructions. Now, data transfer instruction means you need to transfer the data from one position to another position, source to destination. So data can be transferred in this way, so that the previous content of source cannot be modified. That would not be modified, or that will not be altered anyway. So after transferring the content from source to destination, whatever be the destination data, that will be same with the source data. So source data was not modified after transferring the data. That's why this data transfer instruction is called also the data copy instruction. Data copy instruction is just copied from one position to another position. Okay, so that the source is not modified, or it is not altered after the transferring of the content. So the data transfer can be implemented either from the memory to internal register, because the memory which is external to the processor. So memory to internal, and memory from internal to memory, from uh, uh, from one register to another register, and it's register to register, from input port to internal register, that is input output devices are external to the processor, so any input can be transferred from the input device to the register, or from the register to the output device, and that is called the internal, from internal register to output port. Okay. Now there are several types of data transfer instructions are available, like move, push, pop, exchange, translate, in, out, load effective address, load the segment address, and all of this. So these type of instructions are available. Now I will discuss the major instructions among these data transfer instruction. That is the first instruction which is under this category data transfer instruction is move instruction. Okay, and all of you have seen that in 8085 there was move instructions, but in 8085 there are two types of move instruction. One is MOV, another is MVI. Okay, in this microprocessor 8086 microprocessor, there is no I related move instruction, only MOV instruction is available. And MOV instruction is written in this way, that is the general format and the syntax. How can you write this? Move one destination register comma source register. Assume this is the example. That means move vx comma 00f2. Okay, so that is the data byte which will be loaded inside VX register. It's a 16-bit data, that's why it is a 16-bit register. Now, always you need to remember that the size of your source must be equal to the destination. Means if you have used the 8-bit content, then you need to store it in 8-bit register. If you have considered a 16-bit content which will be transferred, you need to load it inside 16-bit register. Okay, so if 8-bit data is to be transferred, then 8-bit register is to be used as your destination point, and if 16-bit data you have considered, then you would like to consider the 16-bit register to store it as a destination point. Okay, and here move CL comma within third bracket, that is 2000H. What does it mean? That means it's a memory location. So within bracket, it always signifies that it's a memory location. In this memory location, there is a data. Now each memory location can store maximum 8-bit of data. That 8-bit of data should be moved into CL register. Okay, so data which is stored inside this 2000 memory location will be moved into CL register. Okay, and the next is the move DS comma CX. What is the content in CX? That will be moved into DS DS segment registers. Okay, so in this way you can write the move instructions. The next instruction is the push instruction. Now push instructions are used to operate the stack memory location. Now, what is stack? Stack is a group of memory locations in RAM where you can store data byte temporarily in structured form. Now if you want to store any data byte onto the stack, means some memory location, on some memory location, those are used as your stack. That operation can be implemented or can be processed using two types of instructions. One is the push instruction to enter the data byte into the memory location, and to retrieve the data byte from the stack or memory location into the corresponding register using pop instruction. Okay, so push instruction and pop instructions are available to operate the stack. So here assume one example is given as push AX, push the content of AX register onto the stack. Now if this is your this position, this is your memory location, so these memory locations has certain addresses, unique addresses. Each address is given. Now to access this, suppose this location, this area, this portion is used as your stack memory location. Okay, so that is the stack segment. So you need two addresses. One is the segment address, another is the offset address. So segment address always should be segment address is there and offset address is there. Now the combinations of these two addresses, you can generate the 20-bit physical address. 20-bit physical address. Is it clear? Is it clear up to this much?
Yes, sir.
Okay,
Sir.
and now 32 participants has joined this meeting. Now I have logged this meeting. No one can join this meeting. Okay, so if you have any pending participant, he or she must be wait. Okay, so no one can join after this. time. I have already locked my meeting. Okay. Okay. So coming to the next section, that is how push instructions can be operated. Now you need two addresses. One is the segment address, which is the stack segment address, which is SS stack segment. And if it is used as your segment address, then there must be one offset address, which is stack pointer address. Now assume the stack segment address is given as 2000 and stack pointer address is given as FFFF. Then what will be the physical address? That should be 2FFFF 10 into 2000 plus offset, that is plus FFFF. Do you have pen and paper with you? So if you need to write it, please write. Stack segment is 2000, stack segment SS equals to 2000, SP stack pointer equals to FFFF. So stack segment is your segment address, stack pointer, that is the offset address. Now what is the rule to calculate the physical address? That is segment address into 10 plus offset address. So 2000 into 10 plus FFFF, which is equivalent to 2FFFF. Okay, so that is the physical address where the stack is initialized. Now this initialization location cannot be used to store any data byte. The data byte must be stored before this memory location. So always stack will be decremented by 1 to store anything inside this memory location. Is it clear? If A2FFFF is there, this location is address is this one, then what will be the previous location? That will be 2FFFE. What is the previous location of this? 2FFFD. What is the previous location of this? 2FFFC, then 2FFFB, then 2FFFA. So in this way, the stack memory location will be decremented by 1. Okay, so it is initialized as 2FFFF, and when this will be decremented, it is decremented in this way: the F, E, then D, then C, then B, then A, in this way. So after now to store any data byte according to this example, which is given as push AX, push the content of AX register. Suppose AX register holds this data byte 5522. Now 55 is loaded inside AH and 22 is loaded inside AL. So total is AX register, but it is divided into two parts. Now when push instruction is executed by the microprocessor, the memory location will be decremented by 1 and the content of AH will be stored inside this memory address. Again, at the same time, when it is entered into this memory address, again this memory location will be decremented by 1. Now the location is 2FFD, and the next content, which is the lower 8 bit of that register, will be entered into this memory location. Okay, so first the higher 8 bit will be stored, then the lower 8 bit. Now before storing the data byte, the memory location must be decremented by 1. So at last, when these two data bytes are stored inside this stack memory location, stack pointer is automatically decremented by 2. One is here and another decrement operates here in this position. So 2 decrement operation is already performed. So every time when any data byte is to be stored inside any stack memory location, the stack pointer memory location, these are all are stack pointer memory location. So this stack pointer memory location will be decremented by 1 every time to store any 8 bit of content. Okay, then this is used to store the content inside stack memory location. And just opposite to this one, to retrieve the data from the stack into the register, what happened? First the lower 8 bit, because all of you know that the stack is performed in last in first out structure, LIFO, last in first out. So which is stored last, that will be processed first when you need to pop it or retrieve the data. The lower 8 bit will be processed first, then the memory location or stack pointer memory location will be incremented by 1, and the content from this memory location will be stored inside AH register. and after that it is again incremented by 1, so that it goes into the top of the stack memory location where it is initialized. Okay, so one increment operation is performed here and another increment performed is here. So again, for pop operation, the stack pointer must be incremented by 1 because it is in reverse order. First it is D, then E, then F. Okay, so when push instruction is used, the stack pointer will be decremented by 1. When pop instruction is used, the stack pointer memory location will be incremented by 1. Okay, so after each push and pop operation, so the stack pointer will be either decremented by 2 or incremented by 2 respectively, for push and pop operation. Okay, so is this clear up to this much? Is it clear?
Yes, sir.
Yes, sir.
Push and pop instruction. Okay.
Yes, sir.
No, sir.
Yes, sir.
Sir,
Yes, do you have any queries?
শ্রেয়সী ঢুকতে পারছে না বলছে সিআর।
Why she is so late?
স্যার লেট না স্যার, অ্যাকচুয়ালি মাঝে মাঝে নেটওয়ার্ক প্রবলেমের জন্য কিছু কিছু লোকজন বেরিয়ে যায়, তো বেরিয়ে গেছে ও।
এসেছিল বেরিয়ে গেছে।
Is she there?
না স্যার।
Okay, now coming to the next section, next instruction, that is the in and out instruction. Both are both input and output that can be used for or used to interface the IO devices, input output devices. Now in instruction is used to read any data byte from the input device, and out instruction is used to process the data to the output device or give the result on output device. Okay, so in means read operation, out means write operation. So in that can be written in this way: in AL, 0F8. So this 0F8, actually this is the address where the device is connected, because microprocessor can identify which type of devices is there, whether it's a light or fan or anything LED or any 7-segment display. Microprocessor can identify. Microprocessor only identify the address of that particular device by which it is connected. Okay, so something that can be read through the address, from the address, and something it needs to write, that must be written onto the address. So address is the main part by which the microprocessor can identify the devices. Okay, each devices. So so in can be like this one, like here in AL0F8 means what is the status given in this address, that must be read and stored inside AL register. This is always, these registers, the initial registers are the destination point, and the second thing or second register or the data, these are the source. Okay, always this can be written, this can be moved in this way. Okay, from this position to this position. Now one thing you have to notice, or you have to write down, otherwise you have to remember it, that only DX register. Now how many general purpose registers are present? 4: AX, BX, CX and DX. Now AX and CX, it has nothing, means it can be used to store the A, B, C, D. All these are used to store the 16-bit data as well. But BX has certain extra operation that is used. It is this BX register can be used to store the offset address. That's why it is called the offset register. Now DX register also used as the second function as port address, to hold the port address. So any port address can be given inside DX register, like here these two example, move dx comma 30f8, then in al comma dx. So what is done in these two instructions? Now 30f8, that is the port address which is initialized or which is stored inside dx register. Now dx register holds this address. Okay, so dx register hold this address which is the port address. Now from that port address something is loaded, means any input or any status is stored inside that address, that must be given to the accumulator. So in al comma dx means what is given inside this address, that must be stored inside al. This is the function of in al comma dx. So only dx register can be used to initialize any port address. You can't write move cx comma 30f8, or you can't write move bx comma 3048 or ax comma 3048. Okay, f8, sorry. Now only dx can be used to initialize it as your port address. So dx is used either to store any 16-bit of data, or it is used to initialize any port address, input address or input device address or output device address. No other register can be used in spite of this dx register as your port address register. Okay, so in and this is the out instruction, the same thing. What is stored inside this al register, the result which will be transferred to this port address, so that the device which is connected through this port address, that must be operating. Okay, something, suppose here 10 is there, result 10, you need to display it on 7-segment display. Okay, or some LCD. Now that LCD is connected through this port address, through which that result should be written inside this address, and using this address the result will be displayed on the LCD display. Okay, so in this way in and out instruction can be used, and when it is used, dx register can be used to initialize the port address. Is it clear? Clear?
Yes, sir.
Yes.
In and out instruction.
Yes, sir.
So where is Shreyoshi? Is she there?
স্যার হ্যাঁ এসছে স্যার, অ্যাকচুয়ালি বেরিয়ে গেছিলাম হট করে, বুঝতে
Why?
পারলাম না নেটওয়ার্ক প্রবলেমের জন্য।
Oh.
নেটওয়ার্ক প্রবলেমের জন্য আই থিঙ্ক।
Okay, so coming to the next section, which is the next instruction, not the section actually. That is the exchange instruction. Exchange instruction. Now this exchange instruction actually exchanges the data between two registers, or like this one, exchange destination and source is given. Destination and source. So destination register can be any register, ax, bx, cx, dx. Source can be any register, and if it is written as exchange bx comma cx, what does it mean? Exchange word in cx with the word in bx, so both the content are exchanged with each other. So content of cx will be moved to bx and content of bx will be moved to cx, so both the register content will be exchanged to each other. So if 16-bit content is to be exchanged, then you must use the 16-bit registers, and if 8-bit content you need to exchange with each other, you need to use the 8-bit register. Okay, the next is this one. So go to the next classification of the instruction, which is the arithmetic instruction. So until now we have discussed about the data transfer instructions. Right now I would like to discuss about the arithmetic instructions. Several arithmetic instructions are available, like add, addition, to perform the addition, subtraction, multiplication, division. So that is the extra feature in 8086 which was not present inside 8085 microprocessor, means the multiplication, division direct instructions was not available in 8085 microprocessor, but in 8086 microprocessor there is a single instruction to perform the multiplication or division. Now let's start from the addition instruction. So add instruction can be written in this way: add, the first is the destination comma source. Now if it is written add AL comma 0F, what does it mean? Add the content of 0F to the content of AL, and the result must be stored inside AL. Coming to the second example, add AX comma BX. AX, so BX must be added to AX and the result must be stored inside AX. Add AX comma 0100, which is the direct value, 16-bit value, where 0F, that was 8-bit content, 0100, that is the 16-bit content. For 8-bit addition, you need 8-bit register, either AH or AL, and for 16-bit content, you need to add, use the 16-bit register, either AX or BX, any register. So add AX comma 0100 means addition between the content of this 0100 with the content of AX, and the result must be stored inside AX. Add AX comma BX can be written also. The meaning of this instruction is addition between the content of BX with the content of AX, and the result must be stored inside AX. Okay. Now you can use in spite of AX in the destination, you can use BX or CX, any register. Like if it is written add BX comma CX, add BX comma CX. So what does it mean? The content of CX must be added to the content of BX, and the result must be stored inside BX. Okay, so that is the beauty of this microprocessor. That means in 8085, what was the criteria? That means one number should be stored inside accumulator, which will be added to the specified register, and after addition automatically the result must be stored inside accumulator. So without accumulator you can't perform any arithmetic and logical instructions. Okay, that was in 8085, but in 8086 there is no such instruction, or it is not accumulator oriented operation. You can use any register to any register operation. Like in this case, you can use add BX comma CX also, and the result will be stored inside BX. You can use CX comma DX also, where CX and DX must be added and the result must be stored inside CX. Okay, so any register can be used to add with each other and can be used to store the result, which is as your destination part. Okay, that is the add instruction. Now that is simple addition. Now if addition with carry is there, then that must be written using ADC instruction. ADC AX comma BX. What happened in this case? BX must be added to CX with the previous flag bits. If any carry is there in your previous operation, if carry flag is 1, then that carry flag, then that 1 should be added to this AX plus BX, and using ADC instruction. So ADC means add with the previous carry bit using the content of BX and the content of AX. The 3 things must be added: AX, BX, and the previous carry must be added. Okay, so a register to register addition can be performed, or register to memory location, or indirectly, or directly you can add. So there are various ways to represent the addition with carry to perform this operation. Now for subtraction also, here subtraction can be written in this way: sub AL comma 0F. Now always subtract can be if it is used in this format, sub destination comma source. So the register which is given or written initially, that is the destination register. The register which is specified second next to it, it's called the source register. Okay, or if it is between any number to register, then the register which is initially is written is called your destination part, and the number which is to be subtracted from this destination part will be your second operand. Like in this case sub AL comma 0F. The function of this instruction is 0F must be subtracted from the AL, and the content must be, or and the result must be stored inside AL register. Okay, so always the second one, which is your source, must be subtracted from the destination. Okay, always the source must be subtracted from the destination. Like in this case, sub AX comma BX, what is given? AX minus BX, and the result must be stored inside AX. So here BX is your source register, AX is your destination register. So always the source register must be subtracted from the destination register and the result must be stored inside the destination register. Okay, here also the sub AX, 0100, this is the immediate data which must be subtracted from the AX register. Sub AX, memory location also, where the memory location content must be subtracted from the AX register and the result must be stored inside the destination part or in AX register. Okay, in the same way, so this is the sub instruction. There must be sum with sub with borrow, subtract with borrow, the same thing with the ADC, add with carry, and here this is for subtraction, which is called the subtract with borrow. Now the carry flag means the borrow. Here in this case, if this is 1, that must be subtracted along with these two contents. Okay, so AX minus BX minus, suppose this one is given as SBB AX comma BX. What does it mean? AX minus BX minus 1. This one is your carry. Okay, that is the carry bit. So that bit should be subtracted from these two contents. Okay, and that is the use of this SBB or subtract with borrow instruction. Next is the compare instruction. All of you know the compare instruction is basically one type of subtraction operation, but the difference is between the subtraction and compare. What is the difference? In subtraction, there must be one result which will be stored inside the destination register, but in case of compare instruction, it is subtracted but no result will be generated. Only three conditions will be arise. Like in this case, CMP CX comma BX means either CX is equals to BX or CX is greater than BX or CX is less than BX. Now, if according to these three conditions, there will be change in flag status. This is carry flag, this is zero flag, and this is sign flag. Now, if CX is equals to BX, then there will be no carry because CX minus BX actually 0. So if the result is 0, means zero flag must be set. In that case, zero flag is 1, but carry flag is not 1, so it is 0. Carry is reset. If CX is greater than BX, means the destination CX minus BX. If CX is greater, largest one compared to the BX, then there will be there any carry? No, there will be no carry. So and the result is not 0. So both are carry and zero flag, both are 0, 0. And if CX is less than BX, means the upper data is the smallest one, like 3 minus 5. Okay, so there must be some carry. So carry flag must be 1, but it is not the 0 result. Result is not 0, so that's why zero flag must be reset. And carry flag must be 1 because of the borrow. Okay, which is again one type of carry. So CMP CX minus BX means CX minus BX, but it gives certain conditions based on which you can create your logic to process the instructions for the instructions. So CMP AL comma 01 also compare immediate number 01 with the AL. Okay, compare CMP BH comma CL, also the compare CL with byte BL. Okay, so here this is the destination, this is source. Okay, in this way you can initialize. Next is the increment and decrement instruction. Now these are very important instruction because you need to increment the content of any register by 1 or decrement the content of any register by 1. So now increment should be processed in this way, INCAL. If it is written, then what happened? AL will be AL plus 1. If INC AX is given, then AX will be, new value of AX will be AX plus 1. Suppose AX contains 0003. Okay, now you have used INC AX. What happened? AX will be 0004. DC decrement AL, and the new value of the AL will be AL minus 1. So the content of AL should be decremented by 1 every time. DCAX means the AX, the new value of the AX will be AX minus 1. The content will be decremented by 1. Okay, so clear up to this much, everyone?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Okay. Do you have any queries, any doubts regarding this arithmetic instructions and data transfer instructions?
No, sir.
স্যার
Yes.
5008 এর মেমোরি অ্যাড্রেসটা মানে কত বিট অ্যাড্রেস? 16 বিট অ্যাড্রেস?
আরেকবার বলো, বুঝতে পারলাম না, ভয়েসটা ক্লিয়ার আসছে না।
5008 এটা কত বিটের মেমোরি অ্যাড্রেস? 16 বিট। 5310
5
এটা
0
কত বিটের মেমোরি অ্যাড্রেস?
কত বিটের মেমোরি আছে তুমি বলো।
16 বিটের কি?
কি করে বুঝলে 16 বিটের?
এই তো তিনটে আছে, একটা 0 চারটে করে একটা বাইনারি হবে।
গুড, তাহলে 16 বিটের।
তাহলে স্যার উপরে মানে এই পেজটা একটু উপরে নিয়ে যান আপনি।
আচ্ছা,
মানে একদম প্রথম পেজে নিয়ে যান।
এইখানে এই
না স্যার,
জায়গায়?
এরও প্রথম, এরও আগে স্যার।
এর আগে তো কিছু নেই।
না স্যার, একটু নিচে নামান, আর একটু নিচে। হ্যাঁ স্যার, এই জায়গাটা আছে সিরিয়াল রেজিস্টার।
বলো।
এর উপরে স্যার, এর উপরে পুশ ইনস্ট্রাকশন।
হ্যাঁ, এইটা
পুশ ইনস্ট্রাকশনের উপরে। হ্যাঁ স্যার, এটা স্যার এইখানে দেখেন স্যার একটা এক্সাম্পল আছে মুভ সিএল আর 2000H। এইটা কিভাবে ট্রান্সফার হচ্ছে স্যার? 16 বিটের রেজিস্টার, সরি 8 বিটের একটা রেজিস্টার আছে, আবার 16 বিটের কিভাবে ট্রান্সফার হচ্ছে?
16 বিট, এইটা হচ্ছে মেমরি লোকেশন। এক একটা মেমরি লোকেশন সব সময় 8 বিট কন্টেন্টই স্টোর করতে পারে। এইটা মানে কিন্তু অ্যাড্রেসটা ট্রান্সফার হচ্ছে না, এটা মানে হচ্ছে এই মেমরি লোকেশনের মধ্যে যে কন্টেন্ট আছে সেই কন্টেন্টটা ট্রান্সফার হচ্ছে। মেমরি লোকেশন থেকে কন্টেন্টটা ট্রান্সফার হচ্ছে, মেমরি লোকেশন ট্রান্সফার হচ্ছে না।
ওকে স্যার।
Okay, so within third bracket means it's a memory location, it's not your data. হ্যাঁ, থার্ড ব্র্যাকেটটা যদি আমি তুলে দিই, থার্ড ব্র্যাকেট তুলে দিলে ইটস আ ডেটা, আর থার্ড ব্র্যাকেট থেকে গেলে ইটস আ মেমরি লোকেশন যার মধ্যে একটা ডেটা আছে। এক একটা মেমরি লোকেশনে একটা 8 বিট ডেটাই থাকে সব সময়। এখানে যে থার্ড ব্র্যাকেটটা নেই, দ্যাট মিন্স 00F2, দ্যাট ইজ দ্য ডেটা, ইটস নট ইওর মেমরি লোকেশন। এই দুটোর মধ্যে ডিফারেন্স হচ্ছে, এখানে থার্ড ব্র্যাকেট ইউজ করছি, দ্যাট মিন্স মেমরি লোকেশন, এখানে থার্ড ব্র্যাকেট ইউজ করছি না, ইটস আ সিম্পল ডেটা। This is 16 bit data, this is 16 bit memory location. Within this 16 bit memory location there is a data which is 8 bit in size. That data should be moved to CL. Now CL is your 8 bit register and data is your 8 bit register, so 8 bit content will be loaded inside 8 bit register. Is it clear? Is this clear?
Yes sir, yes sir.
Okay, so I have 1 minute to end this meeting. Now after this session, again all of you must click on the same link which I have given, okay, for this meeting. You have to use the same link and come to this next session, join this next session after 5 minutes. Okay, এই মিটিং এর যে লিংকটা আমি গুগল ক্লাসরুমে পাঠিয়েছি, you must click on the same link so that you can come after 5 minutes and join to the next session. Okay, which will be started after 5 minutes from now.
Okay, so but 5:10 থেকে আরেকটা ক্লাস আছে স্যার আমাদের।
So 4:40 up to
হ্যাঁ,
তো
নেক্সট ক্লাসটা তার জন্য বলে দিলাম, ম্যাম বললো তো।
হ্যাঁ ঠিক আছে, so 5:10 তো
5:10, okay,
15 or 20 minutes more. Okay,
হ্যাঁ, okay sir.
okay. Okay, so